So it's time to get started. My name is Brian Ketelsen, and I'm a cloud developer advocate at Microsoft, just like it says up there. Today we're going to talk about microservices in Go using the framework Go Micro. The website for Micro is at micro.mu, and it's a pretty good website. It has lots of good documentation about your choices and getting started in Micro. But first, we have to have the obligatory About Me slide. So I've been using Go since 2010. I co-host the GoTime.fm podcast. You can listen to us live every Thursday. I'm the co-author of Go in Action from Manning Press, and the co-organizer of GopherCon, the largest Go conference in the world, held every year in Denver in the United States. So in this talk, we're going to go from zero to distributed microservices in less than an hour. So it's time to buckle up. I have maybe 300 slides and no code. I'm just kidding. I have maybe 5 slides and 40 minutes of code, which is much more fun. So let's quickly talk about Micro. Micro is an entire ecosystem. It's not just a framework. It's not just a toolkit. It's not just a command line application. It's a whole ecosystem. Micro has thought about the developer experience for building microservices, I think, better than any other tool I've ever used in all of my many years of computing. Micro was built for the developer, but it works for operations. One of my favorite things about Micro is that the entire ecosystem is pluggable. So you can choose a different message broker if the one that Micro provides for you doesn't meet your needs. You can choose different encoding or decoding. You can choose a different message transport, and you can choose different ways to collect metrics. Nearly every choice in Micro has a default that is good for developers, and there are many optional replacements. So let's talk about the abstractions that Micro provides you. At the center is the service. The service is business functionality that you need to expose to the world. There is a server that exposes that service, and there's a client that connects to that service. We also have the concept of a broker so that you can pass messages or events back and forth between services. There's a codec, which you use to encode or decode your messages. There's a registry that you use to find other services that you want to call. And a selector, which, if you're familiar with Kubernetes, is very much similar to the concept of the Kubernetes selector, in which it allows you to choose which servers that you're going to talk to by choosing a set of labels. And then the last abstraction is the transport layer. You can choose any transport layer that Micro supports, from crazy transports like UTP, which is built on top of the BitTorrent protocol, all the way down to regular HTTP or straight TCP. So let's talk about the broker first. The broker provides transportation for your events. Micro can emit events, and any interested service can subscribe to and take action upon those events. The default broker is HTTP, but you can see from the slide there are a lot of options for your broker choices. You can go from cloud pub subs like Google and AWS all the way down to NATS or RabbitMQ. The default that's built into Micro is an HTTP broker. That's great when you're working in a development environment, but it's not the broker you should put in production. Codecs. Again, we have a lot of choices. BSON, JSON, Mercury, Message Pack, and protocol buffers. The default is Proto-RPC, which I think is perfect everywhere. If you have an environment that uses JSON RPC or BSON RPC, either one of those is fine, but Proto-RPC doesn't need to be replaced to be in production. The registry. So the registry is how we do service discovery. How do you find the other services that you want to call? How do you figure out which services are providing the functionality that you need to make a call to? The default is console service discovery, but you can also use etcd version 2 or 3. You can use Eureka if you like the Netflix suite. You can use Gossip, which only works on a local area network. It will not route. You can use Kubernetes, and Kubernetes is my particular favorite because when you use Kubernetes Service Discovery, you really don't have to do anything else. It just works. Multicast DNS, if you're working on a laptop and you don't want to run console, you can run multicast DNS. It's the slowest of the service discovery methods, and MDNS does not route, so MDNS is great for local development, but nothing else. You can also use NATS or Zookeeper. Either one of those is fine too. The default console works great for me when I'm in a development environment that doesn't have Kubernetes, but when I do have Kubernetes, that's what I use. The selector, this is how clients choose the instance of the service that they want to use. An interesting selector is the blacklist selector that applies the circuit breaker pattern to your services. So if a particular service fails more than 3 times, it's removed and put on a blacklist. So this allows you to create a circuit breaker pattern on the client side as well as the server side. The default selector is the cache selector. This creates a random hash choice of services to load balance across on the client side. You can use label-based selectors. Again, like Kubernetes, you can create prioritized labels that allow you to pick a service that is closer to you, perhaps, if you make a label for every data center, or you can make labels based on the speed of the server. So you prioritize faster servers rather than slower servers. We've got a named selector. That's useful if you're using a message queue as your transport layer. And then the static selector, and that is if your services are already being balanced by something upstream, for example, Kubernetes. So if you're using Kubernetes, the static selector is what we would use. Transport. How are we going to get these messages back and forth? Our options are gRPC, HTTP, NATS, RabbitMQ, TCP, and UTP, which I mentioned before, which is a UDP variation of the BitTorrent protocol. I've never used it, but I hear it's really fast. I don't know. Being as old as I am, I don't think I'll ever trust UDP, but it's worth a try. The default transport is HTTP, so you're sending protocol buffer messages over HTTP in the default. I've used NATS and RabbitMQ in production, and both of them perform really well. So you can see that all of the batteries are included in Micro. You don't have to make decisions until production time. So because all of these choices are kind of overwhelming, the defaults are built for you, the developer, not to have to worry about them until it's time to go to production. In production, you can change any of the options without redeploying your code, without changing your code. So if today we decide we're moving to Kubernetes, we don't have to recompile anything. All we have to do is set command line flags to say, use Kubernetes instead of console. That's kind of awesome. I like that a lot. So that's the last slide. Everything else, code. Let's build a new microservice. After you install Go, how many people use Go in production? How many people use Go not in production? Awesome. Anybody used Micro before? Awesome. All right. So this will be an instructional demo then. So we'll start off by installing Go, which I've already got here, and then install Micro. To install Micro, we do go get github.com micro/micro. And that installs the micro command, which we'll use to generate microservices. So if we type micro from the command line, you can see that the micro command has several subcommands: API, bot, registry, query, stream, health, stats, list, register, deregister, get, sidecar, new, run, and web. Since we're building a new microservice, we're interested in new. So we'll do micro new -help. And that tells us that we need to know a service name and then perhaps a service type. So let's clear so you can see it on the top. Micro new type equals SRV, And we'll give our service a name. Let's call it hello. So it created the boilerplate for a new microservice for us. And an interesting thing to note is that my Go path is my home directory on Linux. So home Ketelsen is my Go path. All the source code for all of my Go projects is under the source directory, src. And because I gave it the name hello, it generated this project in the root of my Go path. The one mistake I make every single time I create a new Go microservice is not putting the full Go path in for the service name. So let's delete that. And this time, let's give it a full Go path to where I want this to live. So we'll do github.com, bketelsen, talks, Codemotion, hello. All right, so it generated a lot of files for us. It gave us instructions on how to download the protocol buffer generators for Go Micro. And then it gave us probably the most important instruction, which is the instructions on how to compile the protocol buffers themselves so that we can bind to the service. All Go microservices use protocol buffers between the code generation and the transport layer. So if we want to be able to talk to any microservice, we have to first generate protocol buffers. If we want to create a microservice, we have to first generate protocol buffers. So I'm going to cut and paste this command and build my protocol buffers for it. Maybe. And it compiled example.proto into a protocol buffer generated file for Go. So let's go find that. Oh, I put it in the wrong place. It's not in here. All right, we'll use NeoVim. All right, so you can see that here it is, greeting. Am I in the wrong place? I just need to go up one. All right, I'd rather open it in code because it's easier to see. There we go. All right, so we'll start with the things that were generated for us. We have, oh, this is still the wrong folder. Bear with me. There we go. Hello. Much better. Okay, so it generated all of this code. I haven't written any code yet, and this is our main. So main should tell a story. What are we going to do in this application? The first thing it does is create a new service, and that service is a micro abstraction for something that's going to provide functionality that others can call. It registers handlers for that service. It registers subscribers for the events that can be generated by that service, and then it initializes the service and runs it. So let's look at the protocol buffer definition for the service that was generated for us. If we've used protocol buffers before, this isn't new. We have protocol buffers 3 version up at the top, a package name of go.micro.srv.hello. This naming scheme is very common in micro. You'll see lots of dotted naming schemes where the service name is the last, the service type is the next. Sometimes there's a version number in there. And then there's a namespace. In this case, the namespace is go.micro. When you're making your own services, you can use any namespace you want. So we have a service called example that defines three services, 3 functions that it provides: call, stream, and ping pong. The call function accepts a request message, and it returns a response message. So a request message is defined as having a single string variable called name, and the response is defined as having a single string variable called message. Again, nothing exciting if you've used protocol buffers before. The Proto-C compiler turns that into Go code, and this is generated code, so it's not very pretty, but it's very functional. And this is everything that you need to have to create both a client for this service and a server for this service. So once we've defined our protocol buffers and then compiled the protocol buffers into Go code, now all we have left to do is implement handlers. So let's go into the handler package and take a look at the code that's generated here. So we have a struct called example, and that's just the type that implements the interface for the example service. There's a handler for the call request. There's a handler for the stream request, and a handler for the ping pong request. So if you remember, in our protocol buffers, we had a example.call method. In our handler, we have an example struct with a call method. So you can see this implements the example.call interface that was generated by our protocol buffers. The parameters that we get are a context, and then a pointer to the request, and a pointer to the response. That means that we're not returning the response as a type. We're only returning errors. So you modify the response because it's a pointer. You modify it inline, and then return an error if there is an error on the server side. So your messages that you send back to your clients in Micro should only be happy path messages. Don't embed error messages in the response. Just return an error, and that error will be returned back to the client as a pretty wrapped error message. So in our call function, we log the fact that we've received a request. We set the message and the response type, and then we return nil for no error. Pretty straightforward. We also have a subscriber, and this subscriber is the thing that we registered in main, and this is how we handle messages that come across on the message queue. Remember, Go Micro is a microservices platform, not just a microservices toolkit. So in addition to sending RPC requests back and forth, you can emit events and then subscribe to those events and handle them in some way. So if the user service sends an event that says, we have a new user named Brian, then the email service can subscribe to that event and say, there's a new user, Brian. We should send him a welcome email. So you can have a message-driven architecture that's built on both RPC and event design. And I like that quite a bit. In our case, we won't need the subscriber, so it's perfectly fine just to delete that. So back in main, now it makes more sense what we're doing. We registered our handler, we registered subscribers, and we start our service. In order to modify this, in order to change it, we have to change the protocol buffer file. So if we don't want our method to be called call anymore, what if we wanted it to be called greet? That's fine. We change the name of the method to greet, and then we change the handler call to greet. Oops. And recompile, and we're ready to go. So I have an example of this where I've already pre-configured some changes. So this is the exact same service that I just generated. The only difference is I changed the protocol buffer definition to have a greeting of hello and goodbye instead of the call, which was pretty much just hello. So I changed the protocol buffers to have a hello and goodbye function. Hello request accepts a name, goodbye accepts a name, and then both of them return a message. You can see pretty clearly we're going to say hello and then the name that you pass in, or goodbye and the name you pass in. The handlers are tiny. We have a handler that adds hello and the name that's passed in, and a handler that adds goodbye and the name that's passed in. In main, again, we register the handler. I always like to version my microservices with strong version numbers. In the generated code that comes out of the micro.mu command, you'll see that the version number says latest. Is latest a number? No. Just like in Kubernetes or Docker, when you have something that says latest, that's not a version number, that's kind of a tag. So I always use strong version numbers in my microservices. That way I know how to differentiate them when things change. So this is really lightweight. Let's go run this. I told you that Micro uses console for its registry and service discovery by default. So we have to start a console server. So let's type console agent dev, and that will run a single node console cluster for us that won't fail because it doesn't have other members join it. And then open up a new tab and go into greeting. We'll build it, and it compiled. First win of the day. Now, it's very possible, by the way, that there will be lots of failing here. That's what coding is, and that's perfectly fine. I wrote this last night at 2 in the morning while I was watching Stranger Things, which, oh my God, it's a miracle I got any sleep. All right, so we've got our greetings binary here, greeting. So in order to run it, we just type greeting. And you can see 3 log outputs. The first is the port that it's listening on, which we don't care about because Micro does the service discovery for us. The second is the fact that the broker is listening on its own port. And then the third is the fact that our node got registered. Go micro srv.greeting. So what can we do with this? Well, let's see the best way to call, Control-Shift-T, the best way to call a microservice in testing is to use the micro command itself. So you remember all of those options that micro had. Let's go look at some of them now and see whether some of them might be useful. So we could do micro list. Micro list says it needs to know what it's listing. So micro list services. Awesome. It put in a service for console because console is part of the ecosystem. And it also included a service called go.micro.srv.greeting, which is the same service that we just built and started. So if we want to query that service, we need to know how. How do we find the information about that service? We can type micro get service go.micro.srv.greeting. And micro get gives us information about the service. We get the version number at the top. We also get information about the known instances that are running. So we have the service name plus a unique ID for the instance of that service. We've got its internal IP address, which looks like my Docker interface, even though I'm not running on Docker. We've got the port that it's running on, and then some metadata about that service. We know that it's an RPC server, that its registry is console, its transport is HTTP, and its broker is HTTP. Already we have a lot of good information about our service. We know the endpoints that are exposed by the endpoint labels here. But most importantly, we see the request type. So we have a request type that has one parameter called name, and it's a string. So if we wanted to query that service from the command line, micro query, we need to give it a service name, go.micro.srv.greeting, and the method that we're calling greeting.goodbye, and then we need to pass a JSON string. I'm terrible at writing JSON on the command line. I always get this wrong the first 2 or 7 times. Oops. Like I said. All right, so I called micro query, the name of the service, the name of the function, the method that I wanted to call, and then I gave it the request body, name equals Brian. The response on the command line was printed out with a message, goodbye, Brian. So I called the micro goodbye service from the command line using the micro tool. Without writing any code, I actually was able to test this application. That's pretty slick. I like that a lot. So if I wanted to call the hello, I just changed the name of this to hello, and it calls the hello message. So the command line uses the protocol buffer definition to inspect the service that's running and determine how to call it. There are 2 different types of clients in Micro, in Go Micro specifically, because Micro is more than just Go. But in Go Micro, you have a strongly typed client, which is the client that is generated by the protocol buffers. And then you have a weakly typed client, which is just a generic client that the command line uses. So the weekly type client, all it does is pass the JSON in and send it to the consumer. So there's no checking for type consistency in the weekly type client. In your code, if you're calling one microservice from another, you'll use the strongly typed client, and you'll get compiler type safety guarantees. All right, so we've demoed greeting. Let's see what's next. All right, we demoed calling the service, but we only demoed it from the command line. Let's try something even better. If we type micro again, we can see that there's a handful of things we haven't yet done. One of them is MicroWeb. And I have to say this might be, I'm going to say this a dozen times. This is my favorite part of micro. I have a lot of favorite parts of micro. This is definitely one of them. So let's call MicroWeb. And you can see that it generates a listening port of 8082. So let's go to 8082 in our browser. Oh, we're running out of time. It's already 11:56. I'm going to have to talk faster. Okay, so we have a MicroWeb interface of something or other. It says there's no web services found. That's because Micro has the concept of web services, service services, and other things that we haven't talked about yet. But if you look at the registry, you can see the things that are running. We've got the go.micro.srv.greeting service that we just started. So if you click on it, we get the same information that we got from the command line. Information about the instances that are running and metadata about how to call it. But you can also go into the query and query it directly from the web UI. So we just pick the service and the method that we want to call, and then struggle with JSON again. And hit execute. And you can test your microservices from a web interface, which is far better than editing them in the command line. So MicroWeb, probably my favorite way to interact with services in the development environment. That's pretty awesome. So we've talked about calling them and making them and generating them. Let's get a little deeper. Now, we've only got 13 minutes left, so I'm going to only show you 3 different services talking to each other with open tracing and service discovery built in. 13 minutes should do it, right? So in all the code for this, by the way, is in my GitHub repository. Let's open up a level above here, and let's look at a real world, air quotes, real world app that I started to build for GopherCon next year. Every year we struggle, how are we going to build a web application for GopherCon? I hate front-end development, I really do. I can't do CSS, I can't do JavaScript. I can do HTML, but only if there's like a blank or marquee tag, that's it. So this is a web application in Go called GopherCon, and this web application has areas that we want to protect, an admin interface. So we need authentication. So to start with authentication, I built a service called user SRV. User SRV, let's look at its protocol definition, because that's how we figure out what a microservice does in Micro. We look at the protocol buffer definition. You can see that we've got the standard CRUD, create, update, read, and delete. We can search for users, update passwords, log in, log out, and read a session. So I won't bore you with the message types for each of these. After it's generated, we have to create handlers for them. And the handlers are exactly what you would expect a login and password system to be. They check the database, they encrypt passwords, they look for users, they read sessions to see if they're still valid. And then we have a database package that is exactly what you'd expect the database to do. It creates the database if it doesn't exist. It creates the tables and migrates them up if they aren't there. And then we have methods for pretty much each of our operations. So if you're going to delete a session, you call the delete session query and execute it, and then return the response back to the handler, which returns a response back to the client. So our user service has authentication, login, passwords, sessions. Awesome. Let's build it up. Let's run it. Uh-oh. Got to be in the right directory. All right, we already have console running, so we don't need to start console. But I don't have a database because I forgot to start the database. So let's start the database. Where is the database? There we go. So we have to pass in the database URL as a command line option, and I was forgetting that when I was starting it just a moment ago. But now if we go back to the micro command and do micro list, we have gophercon.srv.user.ot, and that's because I added open tracing to this one. So if we do micro get service gophercon.srv.user.ot, you can see all of that same information that was in the protocol buffer definition. And let's hurry up and go look at how to call that from a web application. So inside a web application, we have a protected handler called protected. And it calls a middleware called authorize that calls protected handler. So protected handler looks to see if you've got a session on the server, if you've already logged in. If you haven't logged in, it redirects you to the login page. The login page calls the user login function, and the user login function takes you to the login.html page, which gives you username, password, and email address. That posts to user authenticate. So this is where you can see how we actually call the microservice from another application. This isn't a micro app, this is just a web application. So we have to create a login request, which is a strongly typed request for our login service. And then we make a call to user.login, which actually uses the micro client to call the service. If the service fails, we put up a warning and redirect back to logging. If it succeeds, we set their session ID in a cookie, and we set their user ID in a cookie, and then redirect them to the welcome page. So let's run this, and we will pray to the demo gods. It compiled. That's a really great sign. So let's look at the home page. And on the home page, since I haven't really changed the web app, you can see all of the different routes. Let's try to go to protected and see if it works. Protected says I'm authorized to see this page because I didn't delete my cookies before this demo. So let's log out. All right, now I'm logged out. Okay, now protected tells me I have to be authorized. So let's go to the login page to log in. Give it my username, my password, and my email address. And we'll log in, and now we made it to the super secret page. Hooray, so we have authentication. Let's go look at the logs and see what it did. It called the Go microservice, and this is the response it got back from the microservice. So we know it worked because I printed the response in the log. The last thing I want to show you in our last 6 minutes is open tracing. So because we're building a distributed system with lots of different microservices that are talking to each other, from clients that we control and clients that we don't control, tracing a request throughout your system is really painful. So the concept of distributed tracing came out of Google's Dapper and Twitter's Zipkin. So I've included all of the information that we need to trace in these applications already. So if we type make Jaeger, this will start. Uh-oh. Oh, I've already got Docker running. All right. So if we go to Jaeger's port, we can see the Jaeger UI for open tracing. Now, because we just ran a login and a logout, we should already have sessions in here. So if we look at our service list, these are all the services that we have running right now, and all of the services that there are traces responding to. So if we go to gophercon.web and search for everything in the last hour, you can see first a pretty graph that shows response times, and then second, a list of spans for which we have tracing. So here's a request that took a total of 81.54 milliseconds, and if we click on it, we get detailed information about it. Gophercon.web is the web server. Its total response time was 0.1 milliseconds. And, oh, I'm sorry, Gophercon, this one here. Its total response time was 81.54 milliseconds, which matches our total trace time. But it called the user login microservice. And because open tracing is smart enough to inject its tracing headers in between these network calls, it actually shows as a child process of the website. So gophercon.srv.userot, which is our microservice, lists as a child operation. And you can see this one was a duration of 1 microsecond. So Go Micro plus MS plus MySQL is a really fast combination for authentication, just FYI. So we can see that our traces propagate across all of the different microservices. So when you give an error code to one of your customers, you can use the trace ID as the error code. That way your network engineers and your operations and help people can go back and they can look up that specific trace and they can say, oh, it's very clear that the MySQL server was down because we got an error in the MySQL part of the trace. It also helps you to determine which pieces of your application are fast and which need help. So that's the demo for open tracing. All of the code for this is at github.com/bketelsen, all E's, bketelsen, and then talks. Hopefully GitHub works today. It'd be awesome if it was down. Well, you'll have to take my word that it's at GitHub bketelsen talks. And inside talks is a Codemotion folder, and all of this source code is in there if you have any questions about it. My Twitter is bketelsen. My email is bketelsen@gmail.com. Please reach out anytime and ask questions. I love helping people get started in microservices and Go, especially the open tracing part. It just makes me happy. So thank you so much for coming to my talk today and learning a little bit about micro.